This is the first video on quadratic number patterns. So when is a number pattern quadratic? Well, the definition of a number pattern that is quadratic is when it has a constant second difference. Okay, now what on earth does that mean? Let's have a look at example 1. In a quadratic number pattern, they will always give you at least 4 terms. So if we work out the difference between 41 and 22, we always take the right-hand term minus the left-hand term, and then we'll see it's 19. 21 minus 9 is 13, and 9 minus 2 is 7. Now this green series that or number pattern that you see here is always linear. So this one is always linear. Okay, so if we take the second difference, 19 minus 13 gives me 6. 13 minus 7 always gives me 6. So the second difference, that is the second difference, is 6. Okay, so that is why we call it a quadratic number pattern. If we work out Tn, the general term for this pattern, we will get a quadratic expression. That means the highest power will be 2. Okay, let's try and expand this series. What will we do if we expand this series? Okay, let's go. So 7, 13, 19, that means the next one in this sequence will be 6 more than 19. That gives me 25. So here I'm going to write a 25. And then the next one in this linear sequence will be 6 more. That gives me 31. Okay, so I know that I must add, because I see this is an increasing sequence, so I must add 25 to 41. And what will I get there? Let's see, this is T1, T2, T3, T4, and T5 will then be 66. And from 66, I have to add 31. So 31 plus 66 is 97 for T6, etc. Okay, so if I subtract these two, 97 minus 66, I will once again get 31. If I say 66 minus 41, I will get 25. And the difference between 25 and 19 would be 6. Between 31 and 25 would also be 6. Okay, so this is how we expand a quadratic sequence. Let's look at example 2. First, we want to see if this is a quadratic number pattern. So we say negative 21 minus negative 12. The term on the right-hand side minus the term on the left-hand side. Always go that way, not the other way. So minus 21 plus 12, that gives me negative 9. Okay, so the first difference is negative 9. Negative 12 minus negative 5 is negative 7. Negative 5 minus 0 is negative 5. That is the first difference. Okay, so now we go for the second difference. Oh, remember that the first difference is always a linear sequence. What is negative 9 minus negative 7? That gives you negative 2. What is negative 7 minus negative 5? That also gives you negative 2, and that is called the second difference. We see that we get negative 2 every time. So this is constant. So this pattern is quadratic because it has a constant second difference. Now we're going to try and expand this pattern. We want the next 3 terms. To do that, we look at the sequence or the pattern of first differences, and we complete the pattern for the next 3 terms. So we had a negative 9, so the next one would be negative 11, and negative 13, and negative 15. Okay, because this pattern is decreasing, we know it will carry on decreasing when we add these 3 numbers from this first difference sequence. So what is 21 minus 21 minus 11? It gives you negative 32. Negative 32 minus negative 13, or add plus negative 13 will give you negative 45, plus negative 15 would give you negative 60. So term 5 is negative 32, term 6 is negative 45, and term 7 is negative 60. Term Tn. Well, the standard form for Tn of a quadratic pattern is Tn equals an squared plus bn plus c. So if we want to determine the first four terms of a quadratic number pattern, you just substitute n with 1, and then 2, and then 3, and then 4. So our standard form for this quadratic number pattern would then be T1, which is a plus b plus c, T2, which is a plus 4a plus 2b plus c, T3, which is 9a plus 3b plus c, etc. Okay, so there is your standard form for a quadratic number pattern. Okay, so if we look at this general pattern and we try to work out the differences, what do we get? Let's work out the first difference first. T4 minus T3 will give me 16a minus 9a, which is 7a, 4b minus 3b, which is 1b, and c minus c, which is 0. T3 minus T2 would give me 5a plus 1b, and T2 minus T1 would give me 4a minus a, that's 3a, and 2b minus b would give me 1b. Okay, so this is our first difference. The second difference would give me that minus that, which is 2a, and this minus that, which is also 2a. Okay, so we see some interesting things here. We see in the first place that the second difference is constant, so this is definitely the second difference, this 2a. Okay, we see that T2 minus T1 is equal to 3a plus 1b. We see that, T2 minus T1. And we also see that T1 was equal to a plus b plus c. So for the sake of determining the Tn formula of a quadratic equation, we're going to use this term here, this expression, and this one. Okay, and the three formulas we're going to use are going to be T1 equals a plus b plus c. It comes from there. T2 minus T1 equals 3a plus 1b. It comes from the second row. And then the third one, the second difference is equal to 2a. Okay, so in this example, we were working with the standard form of any quadratic equation. So it was an abstract one without real values for a, b, and c. So this method you can use to determine Tn of any quadratic number pattern. So all you need to remember is you need to remember these three formulas. Okay, so let's do a nice example. Okay, so our example is going to be the following. The number pattern is going to be 9, 20, 37, and let's say 60. Okay, what you do is exactly what we did up here. You're first going to determine the first differences. That's 23, that is 17, and that is 11. Now you determine the second differences. That is 6, and that is 6. Okay, now you highlight the ones you want. You are going to work with the 9 and the 11 and the 6. So now we know that 2a is going to be equal to 6, and we know that 3a plus 1b is going to be equal to 11, and we know that a plus b plus c is going to be equal to 9. It comes from these three formulas. So now we're going to solve these three equations. We start at the bottom with the easiest one when we say 2a equals 6. Therefore, 1a is 3. So now we've determined a. Now we go to the middle one. 3a plus b equals 11. So 3 times 3, we have the 3 already, equals 11. So b is going to be 2. And then the third one is the top one, a plus b plus c. I already have is equal to 9. I already have a, that's 3. I have b, that's 2. So that is 9 minus 5, which gives me c is 4. So what is my Tn formula? Well, Tn is an squared, so it's 3n squared, plus bn, plus 2n, plus c. And there we have our Tn formula for this number pattern.